So yeah, this unit can be a little bit more challenging. The fact is that the nice thing is you got some review. We're gonna do quadratics today. See, we just came out of functions, and you learned how to transform functions. You learned what a function is. Quadratics are functions. That's gonna be review. But then after that, we talk about operations of functions, such as addition, subtraction, multiplication, division, composition, inverses. And a lot of those things you actually don't know. You don't know what composition of functions is. You have no idea what it is. If I ask you to determine f composed of g of -1, you would not know what to do. Or if I asked you to take the inverse of f of x, given f of x is equal to x plus 3 over x, you would not know what to do in that situation. So that's why it's so important. You're entering an area where you're starting to see stuff that's new. And so therefore your presence is so important. Does anybody see something in the immediate future that will cause them to miss a lot of school? Optional Wednesday, okay. Hit by a train, all right. Optional Monday, Tuesday, Wednesday, Thursday, Friday, okay. College visits. So you can handle a day or two, but you can't handle 4 or 5 days. You decide to go get married over in Spain, that could cause a problem, okay? That's what Trina did, right? So please don't do that. But I also want to talk about being present, okay? And in this piece, are you present in the class? Are you anticipating the next pattern that's developing with the notes? Are you looking ahead to the next problem? Or how many times I just saw the news last night? Average number of hours teenager spends on their phone in a given day. Average. It's 7 hours a day. 7. Average. Average. Please reduce that time in math class. This is so much more important to your success in this unit. Here we go. We want to begin by talking about extreme values because quadratics have extreme values. This is what we refer to as an extreme value. We call it a local maximum, though I know it is not the greatest point of the function. This function heads off towards infinity. So there are definitely points that are greater than that, but that's an interesting part because this could represent, say, the maximum profit of a company. Would you agree that maximum profit of a company is something you'd be interested in? Yeah, like that's a real thing. Like mathematicians solve that kind of stuff. That is also an extreme value. We would call it a local minimum. Now I know that there are values that are less than that, but within this general region, that would be the smallest. We like to find something that because we like to say minimize the number of deaths due to, say, high cholesterol. Okay, that's a good thing to do, right? So maximizing and minimizing is something we like to do. Quadratics do have extreme values. Some of the extreme values for quadratics, all of them occur at the vertex. This is what we call vertex form. We're going to look at that tomorrow. And today we are going to look at what we refer to as standard form of a quadratic. 8x squared plus bx plus c. This should be 100% reviewed today because I know Miss Kruger and Miss Hansen very, very well. I know exactly when they teach this. You guys should have knocked this out of the park, okay? So if I have a parabola like that, it has what we call a vertex. See if you guys can be the first group of the day. Who can tell me how I determine the vertex? How? How without the calculator? Formula. What formula? Vertex formula. What's the vertex formula? You don't know. You all know it. It's sitting in your brain. All right. I'll try a different question. Does anybody here know the quadratic formula? What? I'm gonna try to make you smarter here and see a connection. You now have the vertex. You see, it's negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Like, that's another way of writing the quadratic formula, right? This is the vertex. That's the location of the vertex, negative b divided by 2a. It sits inside the quadratic formula. It's right there, staring at you in the face. Now, what do the vertex and the quadratic formula have in common? It's this vertex thing, because here's what the quadratic formula actually does. It finds the x-intercepts, right? So what it does is the quadratic formula finds the vertex, which happens right here, and then it goes plus or minus. How much plus or minus does it go? It goes square root of b squared minus 4ac over 2a. So does everybody see that the vertex sits inside the quadratic formula? You should never forget it again. It's always right there, staring you right in the face. Once we have the x value, anybody know what we do to find the y value? Plug it in. So f of negative b divided by 2a. And it does have a y-intercept. We talked about the x-intercepts. To find the x-intercepts, you use a quadratic formula or a factor. This y-intercept is just your c value, whatever is there in the end. Because we know that the y-intercept occurs when x is equal to 0. If you make x 0, you see that you just end up with c, correct? Yeah. All right, let's try 2 examples. You guys can get your assignment. Sketch a graph of the given parabola, state the coordinates of the vertex and its intercepts. We're actually going to list the direction. We're going to list the vertex. We're going to list the axis of symmetry. We're going to list the x-intercept and the y-intercept. Okay, direction, up or down, left or right? What do you got? Up. Why? Because the 2 is positive. Very good. Whatever sits in front of x squared determines direction for us. It's up. Vertex, negative b divided by 2a. 2 is the a value. Negative 8 is the c value. C value. So what's the b value? 0. There's no x term. So I have 0 divided by 2a, so 4. And that gives me 0. The x value is 0 of the vertex. How do you determine the y value? When you plug it in, what do you get? Negative 8. Good job. So I have 0, negative 8. I'm going to make a graph here. 1, 2, 3, 4. Made my first pizza in my new oven last night. Good. It cooks a little hotter than normal, so gotta take it out a little bit more quickly than the others. Papa Murphy's, $10 Tuesdays. Any large for $10. 5 people, $10. Good deal. We plot the negative 8. The axis of symmetry. The axis of symmetry is an imaginary line that runs right through the vertex. Okay? Right through the vertex. And it's a vertical line. How do we write the equation for a vertical line? How do we write the equation for a vertical line? Very good. X equals. Vertical lines are x equals, and it's the x value of vertex. X equals 0. If you just write 0 on the test, I take off a point, because it's not a point, it's a line. And in order to write a line, you have to list x equals. All right, who can tell me what the y-intercept is? Negative 8. To find the x-intercepts, you take the original function, set it equal to 0. 0 equals 2x squared minus 8. Or factor out a 2. 0 equals 2 times x squared minus 4. 0 equals 2 times x plus 2 times x minus 2. So what are the x-intercepts? positive, and negative 2. I plot those, and you can see I get my parabola shape. Hello. Any questions on that? Going once, twice, thrice. All right, what's different about the next one? Good. We got down, we got a fraction. So we got direction, we got vertex, we got axis of symmetry, we got the y-intercept, we got the x-intercept. So, direction, down. Vertex, negative b divided by 2a. What's negative b? 6 divided by twice the a value. What's twice the a value? Negative 1/2. Oh no, I don't like to divide fractions, so I multiply by reciprocal. So I get 6 divided by negative 1/2 is negative 12. Very good. See if we can figure out the y value. Plug it in, you should get 39. Ashton, did you not get 39? So I go negative 0.25 times negative 12 squared. And then I go minus 6 parentheses, negative 12. I go plus 3. And I should hopefully get a 39 out of that guy. There we go. We good? You're using your phone. Okay. All right, so I'm going to plot this. I'm going to go by 10. So 10, 20, 30, 40. Because it's a free country, I can do what I want. There we go, 2 cents. All right, so negative 1239. So I back up 12, I go up 39. And then I've got a, what's the y-intercept? Three. Just C, it's the number on the end. So I can plot 3. What's the axis of symmetry? X equals negative 12. Got to write the equation for the line. Well, hi, B-Lock, eh? X-intercepts. How do I determine the x-intercepts? Say equals 0. 0 equals negative 1/4 x squared minus 6x plus 3. Now, that looks challenging, but fortunately, you guys are excellent mathematicians, and you're great at solving equations. How do we solve that equation? Doesn't factor. Quadratic formula. I don't want to use the fraction. Times it by 4. I don't like the negative. I'm going to multiply through by negative 4. And I get positive x squared plus 24x minus 12. So now I can solve that equation. Okay? Quadratic formula. You have to list the answers for the quadratic formula in 2 ways. 1, simplest radical form. Number 2, as a decimal. Anybody got a quadratic formula plugged in their calculator? Shelby's got it. She's going to work. Shelby, plug in 124 negative 12 or negative 1/4 negative 6/3. Either one will give you the same answer. What do you get for your x-intercepts? Like negative 0.489, something like that. And then 24.489. You get 2 of them. Try plugging again. Try plugging in x squared try putting in 1, 24, negative 12. Now we got this? Got it. Okay, that's what I thought. Very good. Remember from the other classes. So now simplest radical form, throw it into the quadratic formula. Negative b, so negative 24, plus or minus square root of b squared. What's 24 squared? Minus 4 times a is 1, c is negative 12. All divided by twice the a value. I'm going to determine the value of the discriminant now. The discriminant, because it discriminates, it tells the difference between the types of values. If I have a positive, we have 2 solutions. If I have 0, I have 1 solution. If I have a negative, I get no solutions. So what's 576 plus 48? 624. I'm not really good at knowing my factors of 624. I don't know if other people are. But so we got to kind of guess. Anybody want to guess a perfect square that divides evenly into 624? 18 is not a perfect square, but if it was, it wouldn't divide either. 9, let's try 9. Doesn't work. Give me another one. 16. And we get 39. Hey, there we go. So 4 roots of 39. We good? All right. So we've got negative 24 plus or minus 4 roots of 39, all divided by 2. Because negative 24 and 4 are both divisible by 2, you can write it as negative 12 plus or minus 2 roots of 39. And that is my answer in simplest radical form. So I have 2 results here. I have that, and I have simplest radical form. If I were to graph this, I could then plot the positive 0.489, which would sit right here. I have my x-intercept, I have my vertex, and then I also have the negative 24.89, which is about right there. I should get that kind of a shape for my parabola. And sure enough, if I were to plug it into my calculator, go into y equals and graph that, you can see that it matches very closely to what I have. Boom. There you go, folks.